Move, ball, move! Why don't you just move?
Hey everybody, Dave here. Now, as much as I wanted to, that ball isn't going anywhere just because I tell it to.
This isn't a galaxy far, far away. That's a Star Wars reference. But even in a galaxy far, far away, the laws of physics are the same. To get something moving, or to stop something's motion, a force needs to be applied. Now let's take a look at some of the forces that cause changes in motion.
A force is a push or pull on an object like this ball.
And that was one type of force called an applied force.
And there are many types of forces. There are applied forces, tension, normal force, frictional forces, air resistance, and more. And there are also forces that don't require two things touching, like the force of gravity, the electrical force, or the magnetic force.
There are a lot of forces that push and pull on us.
And some forces are much more adorable than others.
If something is sitting still, it wants to stay that way, and a force needs to be applied to it in order to get it to move, like that soccer ball.
But did you know the same is true of moving objects? They just want to keep moving. Take this car for example. If you're not stepping on the accelerator, it will slow down. Because the force of gravity is pulling down on it, the normal force from the road is pushing up on it, there's rolling friction pushing back on the tires, and air resistance pushing back on the body. Now put a moving car in space, where there aren't a lot of those forces, the car will just keep going forever. Hello, I'm Sir Isaac Newton. I first published my 3 laws of motion in 1687. They describe how and why things move in the universe. Be sure to check out Seriously Dave's other videos about me. And do you like what I've done with my hair?
All motion is predictable if you know the direction and strength of all the forces acting on an object.
Your brain does this automatically when you run. You're not thinking about the friction and gravity and the ground pushing up and the strength of the force you're exerting on the ground and the strength of the air resistance pushing back on you. You just get it. Most of the time anyway. But sometimes you do have to think about the size and direction of the forces you exert, like in games, or sports, engineering, designing cars, or even sending spacecraft to different planets. And now it's time for a force and motion challenge. On this air hockey table, starting by the hamster and behind that white line, we have to get our way past the Velociraptor, Batman, Sven, Harry Potter, around the giraffe and into the circle target. The contestants will have to think about all forces and the motion of the air hockey puck to conquer this physics-filled course. Which path would you take to get to your target? We tried many different angles, amounts of force, and directions of hitting the puck, but it proved to be really difficult to get it in the target. This is harder than it seems because there's almost no friction and you have to be careful with the force you exert. And the obstacles are exerting forces of their own. In the end, we got close, but never quite in the target.
It's all force and motion, and it makes the universe turn. Make sure the forces you exert in this world keep it moving forward. I hope you enjoyed this video.